from 4 until 5 o'clock. There's an awful lot of content in these slides, I'm afraid, so I'm going to gloss over a few of them, but I wanted to keep content in for use in answering your questions, and because the presentations will go out, you then get all that information. You can then potentially use that in your schools or for further study later. So I will romp through the slides to some extent and make sure we get through them in time for plenty of questions answered at the end. Do please ask questions as you go along, and I will pick up on questions if it's appropriate to do so as we go along. Otherwise, we'll have a dedicated 10 or 15 minutes at the end. I will be finishing exactly on 5 o'clock, so as to allow those of you who have signed up for Stephen Walker's webinar at 5 o'clock on skimmed work to get out of this room and then back into the other room to watch his presentation. So here's an outline of the session. We'll take a look at the content and the assessment structures. This is content that a lot of you will have already seen in previous presentations or at the previous conferences, so I won't take too long over this, but it is worth just taking a little bit of time to delve into some more detail about what the content is, where it's come from, and how it relates to the current specification. We'll then take a look at overarching themes and assessment objectives, and how those apply to the teaching and learning, and specifically assessment of further mathematics, along with some examples taken from the sample assessment material, looking at how the mark-by-mark allocation of assessment objectives works, how these sorts of things apply in the various different optional strands. And finally, we'll have a look at the support and resources currently available and planned in the future to help with your understanding and with your teaching and delivery of the course. So without any further ado, let's have a look at the content. So I want to talk first about some of the design considerations that went into developing the content. Again, this is something that many of you have heard, but we had an awful lot of flexibility within the design of the A-level further maths specification. Whilst 50% of the content is a fixed pure core that all awarding organisations have to have as a core to the A-level, there are some decisions to make as to how much of that is in the AS further maths as pure core, and then the remaining part of both of those specifications is left completely up to us. And that amazing opportunity to design from scratch has allowed us to really focus on the end users, that is the students of the qualifications, and the content that they're going to find useful, and the structures that make it good for them to learn that content. We have therefore ended up with 4 very different looking further maths qualifications, which does make things a bit trickier from your end, your point of view of choosing between them. So these are the 4 broad things that we wanted to think about as we were designing. The first, continuity. Of course, this is a wonderful opportunity to design from the ground up, but of course we can't throw everything out and start completely from scratch. It would make it impossible for people to deliver, particularly given the timescales that you have to prepare. So it's important to balance the opportunity to change things and to iron out some of the problems with the current course, the opportunity to reorder the content and bring in things that have been perhaps not focused on in ways that they should have been, but also to make sure that there's enough continuity, that you only have a few bits and pieces to pick up if that's what you want, if you want a continuous path through. One of the major pieces of work we did was this higher education survey, which is a survey of more than 4,000 undergraduates in a range of numeric disciplines, all the way from mathematics and engineering, physics, to social sciences, biology, architecture, accounting, business, finance, economics, and so on, and everything you can think of where there's a mathematical basis. We looked at their experience of mathematics and then further mathematics, if they've done further mathematics as well, looking at the utility of the options that they took, what content they found useful in helping them transition to higher education, what content they didn't think was useful for their particular discipline, and what content they thought would have improved their transition. We also talked to lecturers and so on about their feelings about maths and further maths, and the content that they felt would be useful for their undergraduates to have seen in advance, obviously not in great depth, but to have seen in advance to smooth that transition to higher education. Now, one of the main things that came out of the survey, of course, is that simply doing further maths is a good thing. That students going into mathematical disciplines, if they've done further maths, it's of great benefit to them, regardless of which optional content they pick. And so if you're only able to offer one pathway, don't worry about it. The benefit of having lots of different optional pathways is that students can customize their curriculum, smooth their transition into their particular higher education destination if they have that opportunity. So that's one strand, one major strand of how we decided on what content goes where. It was looking at the end users, the undergraduates, and what they felt about the content. Co-teachability is very important. We're going to discuss this more as we look at the content, but we do need to make sure it's a requirement from the DFE content that AS and A-level maths can be taught in the same classroom, and also that maths and further maths can be taught in parallel. So there is this sort of double thing going on, which does make particularly the design of mechanics and statistics in further maths difficult. But we'll have a look at that when we come back to it. And we must note at this point that the requirement from the Department of Education was that at least one pathway through further mathematics must be co-teachable in this way, in parallel with maths. But every pathway in further mathematics A, so all 6 of the possible pathways here are fully co-teachable with AS mathematics. So that is not a consideration you have to worry about if you're thinking about which options to pick. The last thing was coherence. There are some problems with the way that the current unitized structure chops things up. And we'll see some examples of that when we look at the content. We've managed to take the opportunity to draw together things like, for example, momentum and impulse in 1 and 2 dimensions into the same place, so that you have a much more coherent structure to the course. The final thing we wanted we obviously had to think about was curriculum structure. So it's not just what content should be there, but also what structures that need to operate there. So there's a few things to pick out here. We wanted to avoid structures where AS level further maths and A level further maths exams are on exactly the same content, but at different levels of demand. So if you choose, say, a mechanics option at AS, and then you don't carry on with doing mechanics at A level, you'll end up having exams potentially at the end of year 12 and then at the end of year 13 on the same content, but with different underlying assumed knowledge and at different levels of demand. That's confusing. It's also difficult to set consistent exams with that. The other thing we wanted to do, and a major consideration that came from the higher education survey, was to retain breadth in AS, to allow the qualification to serve the many masters that it needs to serve. And this is not just about maintaining the opportunity to do lots of different things, but to maintain the flexibility to focus or to do many different things. And that's what led us to the AS Third Appeal Core being only a third. We had the option of AS Third Appeal Core being anything from a third upwards of potentially all of the AS Further Maths that could have been pure core. So we tried 50% and we found that we were really putting in content which we felt was inappropriate to year 12s, also putting in content which didn't necessarily serve the sorts of destinations that people who are choosing to only take AS Further Maths were heading for. The other thing that was that whilst one of the big outcomes of the survey was that a lot of disciplines would like students to do more pure maths, as much pure maths as possible, actually the pure maths that they were picking out was not actually in the further pure core. So we took the opportunity, therefore, to keep the further pure core at a third, but to include both then applied options at a third each, and an additional pure content which actually addresses the pure content that engineers, physicists, economists in particular picked out as things that they thought that they should have seen for that transition into higher education. And we'll come back and look at that in a moment. The other thing we wanted to do is to build in the spiral linear forces demand. And this comes back to the first point, that we wanted to avoid a structure where you studied some particular option in year 12 and then never saw it again for another year. And so what we have is a structure where the options that you pick in AS, you then come back to in year 13. There's about a half a current unit's worth of content, which is a top-up on that AS content that then either increases the depth or the breadth of what you studied at the AS. So that you end up with a 1 current unit's worth of content for AS and about 1.5 current unit content for that same option at A level. So there is the possibility to study almost entirely pure, taking the further pure core with discrete maths and additional pure, or to focus on the applied and to do the further pure core with mechanics and statistics and end up with 2/3 applied at AS. So how does this look overall? This is a useful diagram to see how the curriculum works as a whole. Now I should explain what stage 1 and stage 2 mean. We use stage 1 to mean the first 2 terms of the 5-term A-level course, or alternatively the AS course. So it's not quite right to say year 1, because of course if you're teaching A-level that's 5 terms, but it's only the first 2 terms, that first 40% of the course, which is the AS. So in stage 1, the first 2 terms, you have this 1/3 of pure core, which is very similar to the current FP1, and then 2 options, which are about the same size as current units, which we'll talk about the options, the possibilities in a moment. And then in stage 2, and then the 3rd, 4th, and 5th terms of the A-level, you then have these half-unit top-ups in each of the option, which, as I said before, they do increase the depth and breadth or breadth of what you've done in stage 1. There's also time built in there, approximately 12 hours in stage 2 for each of those options, which is simply devoted to spiraling back around that stage 1 content, but learning at a higher level of demand. So there's space allowed for within stage 2 for the spiral nature of the linear 2-year course. And you also have this big dollop then of pure core in the second stage, which is the remainder of the further pure core. Now, I should say that we can see at the bottom of the slide here the options any 2 are statistics, mechanics, discrete maths, and additional pure maths. And learners may take 3 or 4 options, and the best will count. So there is an opportunity. This is unique to OCR specifications, to OCR A and B, that students may take more than the requisite 2 options if they so desire, to increase the breadth or depth of their course, and if they do so, we then take the best 2 results from their final exams. They must take all of the exams, of course, in one session. We then take the best 2 results, or another way of saying it, we take the combination which gives them the best grade at the end. This is one way of increasing the depth and breadth. It's also another way potentially for students who want to do a particular strand, but you can only offer one pathway, which doesn't include that, but they could always study it as an additional option. So here are the options, and this is the assessment structure for the AS. So we have 1 pure core exam, 1 hour and 15 minutes, 60 marks, a little bit shorter than the current unit exams, but that pure core at AS is very similar to the current FP1, the same sort of level of demand and the same sort of length, a little bit shorter. And then 2 of statistics, mechanics, discrete math, and additional pure. So briefly, these are the outcomes from the higher education survey. Was that in statistics we ought to reduce the number of hypothesis tests, but really, particularly the current S2 is the sort of death by hypothesis test setup. One of the key things we had from lecturers in particular was that once their students know how to apply a hypothesis test, they would rather that they were learning other techniques and other things going on, rather than simply learning more different ways of doing it. And in particular, they and students wanted to see chi-squared tests and non-parametric tests make their way into the mainstream. So that's a change going on there. In mechanics, the general thing was don't mess with it. There's an agreed set of content which is appropriate for this level, and everybody seemed pretty happy with it. So it's a matter of picking out which bits to put where and to make it coherent, but nothing really to play around with. Discrete mathematics, with decision maths gone from the fixed content of A-level maths, there's an opportunity really to rethink those decision units and the discrete mathematics offer. And the OCR approach has been to take that and to take it in a slightly more pure and applied direction. So to make it more pure, reduce the reliance on rote application of algorithms. So there's much less rote application of algorithms in the exam, and focus the utility of discrete maths on computer science and economics and accounting, business, finance, who were the only undergraduates really to say, this content was really good for me. Many of them weren't very happy with the current courses, but they did acknowledge that the content would be useful. It's also then, because it has a better pure basis, it's a really good preparation then for students going into mathematics in higher education as well, because they then have a decent foundation of discrete maths. The additional pure maths is the fun bit. This is the additional pure maths is the topics which came up in the higher education survey as topics which were really important for transition into heavily mathematical subjects, but which weren't in the pure core. So this does include things like partial differentiation and surfaces, recurrence relation, number theory and group theory. It's a mixture of discrete and continuous mathematics, but it's about breadth, not depth. So it's about, yes, studying more pure mathematics, but instead of carrying on ploughing through more of the pure content which isn't necessarily relevant, it's about breadth. It's about increasing that wide experience of pure maths at this level and dipping the toes into various different places that might be of use in higher education. It's particularly useful in degree courses such as engineering, economics, physics, where the calculus content is extremely difficult in the first few terms and can be quite an uphill struggle. So having seen the surfaces, partial differentiation, multifunctions at a very low level, a very gentle level, just increases that intuitive understanding and gives a good basis then for them to step off from. At A level, the options are the same because we have this. These are now 1.5 current units worth in size, a bit more content. But so they take 4 exams, 2 pure core exams, which are equal exams. The core content could appear on either of them, and then 2 or more of the 4 optional papers. And so these are about the same sort of size as current papers. We've rounded up to 75 marks rather than the current 72 for some very tedious technical assessment reasons, but it's effectively the same thing. So overview of the content. We'll have a quick look at the pure core, and we'll have a look at each of the options and have a think. So there's I won't dwell too much on the fine detail other than where there is a point of interest. So just a reminder that stage 1 refers to the AS content or the first 2 terms of the 5-term A level. So the pure core, the stage 1, this is very similar to FP1, the same sort of things. Now we chose as our content here this basic setup in proof and complex numbers and matrices, and then we added some work on vectors to follow the work done on straight lines at GCSE and at AS Maths to tie in with that, with vector equations of lines and using scalar products to find angles and so on and so forth. Now we must say that the Spec A includes here a simple treatment of the vector product, which is from outside the DFE content. This is the only extra piece of content we added to the pure core. With the vector product missing from the pure core, there are all sorts of things, particularly in the A level, such as finding the shortest distance between skewed lines and so on, which are really very awkward without the vector product. And it seemed strange to us and to our survey respondees that people could study A-level further maths and not have seen the vector product at all. But it did seem to make sense to include a very simple treatment here. So it's simply given 2 vectors, can you find a third one which is perpendicular to the first 2, but with none of the complexity, and that comes in later on. There's also a little bit there of the further algebra. So this is approximately 1 current unit's worth of content, roughly equivalent to FP1, and the assessment, of course, at roughly that FP1 stage. Now, in terms of co-teachability, there are 3 areas here which require little bits of stage 2 maths, all of which are required by the DFE content. So within complex numbers, students need to know about radians and compound angle formulae. And they also need to know about 3D vectors for the further vector work. Now, these 3 areas are, as I say, required by the DFE content at AS. So there are little bits of additional content you need to teach to your AS further math students before they've seen it in the A-level only part of mathematics. So that's slightly awkward, but we haven't added anything else in. It's only those 3 things as required. And the first 2 of those, the radians and compound angle formulae, are of course current AS mathematics topics. And certainly I've been talking to a number of teachers who have been saying that they'll simply teach that to their AS mathematicians anyway, to make it life easier with further maths. But either way, there's little bits you need to pick up here. Then when we look at stage 2, there's more of the topics in stage 1. So a little bit of top up, extending into things like de Moivre's theorem, for example, and complex numbers, which you wouldn't want to be doing with your year 12s. And then adding in the series. Now these sums of series are currently in FP1, but with series and sequences all out of AS mathematics, it does seem a little strange to then treat them in AS further maths. So we've moved them into stage 2, where it fits better against stage 2 of mathematics. And then standard hyperbolic functions, further calculus, polar coordinates, and the differential equations content is relatively new to OCR. This is essentially the content of the MEI differential equations unit. Now, if you're wondering where all this stuff comes from and how it relates, here is a mapping guide. There's the full details of this in the scheme of work, which is in preparation. But this is roughly speaking where they come from. Those of you not familiar with the unit numbers, 4725 is FP1, 4726 is FP2, and then there's a little bit of 4727 with the differential equations and complex numbers. And 4724 is core 4, so there's a little bit that's just dragged up there from further vectors. And the new stuff is this new content on differential equations. Now, if you're worried about the resourcing, support and whatever else for those, we will of course be resourcing these along with everything else, but there's a big body of existing content there already to go with the MEI differential equations unit. Okay. Now the optional curriculum, I want to talk briefly about statistics and mechanics because these are tricky to set up for co-teachability purposes. So the top line here shows you that there's approximately half a current unit worth of statistics and AS level maths, and then another half a unit's worth of statistics and A-level maths. And to go alongside that, we need to have about 1 unit's worth of AS level further statistics, followed by a half unit top up of the A-level further statistics. And in order for this to be really co-teachable, the 2 AS chunks there need to be teachable together. So that 1 unit's worth of AS level further statistics needs to not rely on the A-level maths half unit of statistics. Now, because of the way the statistics content is divvied up in mathematics, that leads us towards a discrete AS and continuous at A-level model for statistics, and that's approximately what we've done. But of course, from the higher education, that doesn't give you a whole unit's worth of content, but the higher education survey was really pushing us to bring in chi-squared, and so that's what we've done. So this is statistics and maths. This is the discrete, just for completeness, and the stage 2, which has that the correlation and probability, but also the normal distribution, the continuous functions. And then the further mathematics, we then drawn on that. So we have discrete random variables, which does go over quite a lot of the same content as AS mathematics, but it does it in more depth. It does expectation and variance and so on. The correlation and regression, which yes, it does overlap with a little bit of AS maths, but with the A-level math statistics, but it does it from scratch and it does it fully and properly with all the calculations in. Again, from the higher education survey, really important that we got that in. But it has the chi-squared test. These are currently on S3, not because they're hard, but just really that's because where they ended up. But they're a key thing in modern statistics as we move, as modern statistics moves away from a sort of normal distribution-based model, that meeting chi-squared and then non-parametric tests, which are here in stage 2, is a really important thing that we need to do in modernising our statistics curriculum post-16. So the stage 2 then goes into continuous random variables, and it looks like there's a lot of content here. It's just that there's a lot of small topics really, because hypothesis tests and confidence intervals is only a few small techniques. It's about learning the ideas behind it, not about boring everyone by doing lots and lots and lots of them. But the non-parametric tests, they're brought in from S4. Again, not an S4 at the moment because they're difficult, just because that's where they've ended up. But in the new world, they need to be front and center, really. This is a nice web for you to show where bits and pieces come from. You can see it looks like it's bits and pieces from everywhere. Of course, what we've done is we've tidied up, as it were, the leftover bits of Stats 1 and Stats 2, and then brought in those bits of Stats 3 and Stats 4 that are important. It's only that bit of non-parametrics test from the current Stats 4. So in mechanics, we have a very similar setup, again, with this co-teachability issue. It's made more complicated in mechanics because there is the issue of resolving forces. So in the DFE content, as you'll most likely be aware, for AS Mathematics mechanics, students are not required to resolve forces. So forces are always given to them in parallel and collinear or in component form. Now, we tried to make RAS level further mechanics work without resolving forces, and to be honest, it's very difficult. You end up with extremely synthetic concepts all the time. So this is the one place in all of this where there is a bit from the A-level maths which must be taught within AS level further mechanics. It's simply resolving forces. And given that they can already switch between magnitude, direction, and a component form for vectors, there is very little extra content there. So it's just a little conceptual stepping stone, really, to get into that mechanics content. So in stage 1, in mechanics, again, we have to think about AS being co-teachable. So we have kinematics, forces, and Newton's laws, and then we bring on some more of that in A-level and include the statics. So we wanted really to leave anything to do with statics in A-level further mechanics so that you can meet that initial content on moments and so on in A-level maths first. So in further mechanics, this is what stage 1 looks like. We have dimensional analysis, which is new to OCR, but really a fundamental part of learning mechanics. We then have work, energy, and power, which is currently on M2, and then impulse and momentum and circular motion. So really it tidies up M1 and M2, and then leaving M3 and M4 to provide a little bit of circular motion, and then the content for the A level. So this is really just what's left of M1 and M2 on the current course. Stage 2 then adds on to work, energy, power by including elasticity, but also and impulse and momentum by going into 2 dimensions, and circular motion by going into 2 dimensions. So in each case, adding vectors in. So we do things in 1 dimension in AS in stage 1, and then once they've got really solid and happy with vectors in their mathematics, we can add all those vector techniques in. There's a great opportunity here to include scalar product, for example, within the mechanics course. So this mechanics makes much better sense as an application of pure maths than it does now. We also then have center of mass, as I said, building on the statics as an A-level maths, and a little bit linear motion under variable force as a key topic. A very, very small topic, but a key thing for students to have seen. Again, we have the mapping. You can see it's mostly M1 and M2, but then M3 providing those high-level topics, the stage 2 topics in general, and a tiny little bit of mechanics. 4 is only integration for center of mass, which is a relatively simple topic. Okay. So we then have discrete mathematics. This is what the discrete maths course looks like. It looks like an awful lot of topics, and the reason for that is that whilst in statistics, for example, the AS topics are fairly separate from the A-level topics in stage 2. In the discrete maths course, we introduce most of the topics in AS, and then they build on top of that. There's a bit more depth in each of the topics in stage 2. So we have much, again, for those of you not used to the unit numbers, 4736 is our current decision 1, and 37 the current decision 2. So there's quite a lot of D1 in there. There's a little bit of D2 with project management and critical path analysis, which is actually on decision 1 in most current specifications, and game theory, which is a vital thing to have met really for economists in particular, and also computer scientists, mathematicians as well, an important way of thinking about the world, and an important application of modelling. We'll see an example of that in a moment. But we also have some new content, which is really this basis in combinatorics that underlies the discrete mathematics, learning about different sorts of combinatorics problems, and then things like the pigeonhole principle, the inclusion and exclusion principle, and so on, counting problems, which allow you to look under what's going on. The graph networks has been extended slightly into planar graphs and Hamiltonian graphs and so on. So it actually provides a coherent look at how graphs operate. One thing we want to point out here is this move away from a reliance on rote application of algorithms, and in particular that the formula booklet for OCR Spec A includes some sketches of these algorithms, so that you don't have to spend a lot of time in the classroom drilling your students in how these algorithms work. You can relax and spend time thinking about the modeling and the interpretation. And the assessment then looks more at the setup and here is the outcome, can you interpret it in context. For stage 2, it is simply more depth on the previous things plus the simplex algorithm. And we've left that until stage 2, partly because we've got rid of all that rote churning and all the arithmetic that goes on, and we've thought a little bit more about the interpretation of outcomes. So simplex there in stage 2. The additional pure mathematics, so I've already talked about these topics briefly. Some of this is brand new, it hasn't been seen for some years in post 16 with number theory and surfaces and partial differentiation. There's also then groups and further vectors, which talks about which is the vector product and scalar triple product, and the sequences and series, which is recurrence relations, and drawing on the work that they do on second order differential equations in the further pure core, connecting that in with second order recurrence relations. So it makes a really nice coherent whole of the pure content. And stage 2, the same things, plus there's a few little bits of further calculus tying in with these previous topics. So surface area volumes of solids of revolution, for example, things that are on step and that tie in with these topics in stage 1. So again, like the discrete maths, because we really started from scratch with this course, we've been able to build a broad base of topics in stage 1 and then develop the depth in stage 2. So having covered the content there and where things are going, I'd like to just talk about the overarching themes. So again, this is something that many of you will have seen, the overarching themes, which have to be applied across the whole content. Now, this happens in mathematics, but also in further maths. So we need to make sure that we cover all 3 of these within further mathematics as well. And the assessment objectives then follow that. The assessment objectives are Ofqual's tool to make sure that we're covering the overarching themes in similar proportions across the awarding organisations and in similar ways. But of course, within further mathematics, we have this huge amount of flexibility. And these assessment objectives, this is how they link up. These assessment objectives, whilst there are fixed weightings in A-level mathematics, it was up to us to decide on the weightings for our optional content. So that's allowed us in the additional pure, for example, to focus more on the reason, interpret and communicate mathematically, the sort of proof as it were, and the problem solving, and have very little modelling because the content doesn't really apply itself well to that. Whereas in mechanics, we've got much more of a focus on the modelling end of things and much less on the proof. So there's a balance here between the various different strands to make sure that the weightings of assessment objectives are appropriate to whether they're applied or pure units options. So here's an example. This is from the AS Further Mathematics Statistics. This is a question on the chi-squared test. So we have Carl with some proportions of men and women who own black cars. This is his random sample. And we're supposed to test at the 5% significance level whether his belief is justified. Now, I'm not going to go through the content as such, but here is the mark scheme so that you can see how these hypothesis tests work. Now, the hypothesis tests often end up with the same application of assessment objectives, and you can see that it covers all 3 strands. So it covers routine application of techniques in assessment objective 1, where they're simply finding the expected values, and also in simply making arithmetic a comparison, and finally a correct conclusion, all routine. But where the content then is based around language and reasoning, for the first mark, correctly stating the hypotheses with good mathematical language, that comes under AO2, and at the end, making a good conclusion, acknowledging the uncertainty, making it clear that it's inference rather than deduction is an important part of hypothesis testing. And then in the middle, there's a little bit of modeling here. So with assessment objectives 3.3 and 3.4, where they set up effectively model and then use it to find the value of the test statistic. So within these long questions, you often find that the questions are targeting multiple strands even of the assessment objectives, not only elements. So it's very easy to think, well, here are the three assessment overarching themes. Let's look for the modelling question, that's where the modelling marks are. Let's look for the proof question, that's where the AO2 marks are. But the real picture is more complicated than that, with mark by mark allocation. Here's an example from mechanics. So this is again from the AS further mechanics paper, and this is a vertical circles question. I want to draw on this because vertical circles you might think are not doable really with the content in the AS further mechanics, but vertical circles are a special case that are drawn out in the specification, where for AS we treat it with energy considerations only. So here is this is our example then, which is using energy to solve various problems with a vertical circle. The thing I want to pick out here is the command words. So in part 1 we have show that, in part 2 we have prove that, and in part 3 we have find the maximum value. These command words are given in the specification. We have a whole page of command words. They're the same for mathematics and further maths. So it's absolutely clear to students and to you and to teachers what the given command words mean and what the expectation is on students. So as it happens, show and prove are not that different. I should say that words that don't appear in that list simply take their normal English meaning. But the show that obviously indicates that they need to give some working. The proof we tend to use when we indicate something a bit more formal, something with more explanation. And find the maximum value simply requires students to find a value without necessarily any rationale or justification. And again, we can see this in the mark scheme. The AO2 marks, which are for the reasoning and justification, come within the show and the prove that parts in part 1 and 2. In the show that part in part 3, we simply have can they find it? And if they find v equals 7 without the working, of course that's both marks because it simply said find. Whereas in the first 2 parts, some working is required because the command word says show or prove. Here's a nice example from the discrete mathematics. So this is game theory, and maybe that for many of you, game theory is not something you've thought about before. So just briefly, this table gives us 2 players, player X on the left and player Y at the top, each of whom have 2 strategies that they might play. And this table shows payoff for X. And because this is a zero-sum game, whatever X wins, Y loses. So if X plays P and Y plays R, X will win 4 points, as it were, and Y will lose 4 points. Now this is abstract, but of course we can set these in as it were, proper context as well. So the -2 then for P and S shows that X is going to lose money and Y is going to gain. And we can see quite easily this is unstable because should, for example, player X play strategy P a lot or all the time, player Y will quickly cotton on and start playing S. And if player Y starts playing S all the time, player X is losing all the time, they'll quickly cotton on and play Q, which means that they win 1 every time, at which point player Y will switch to R, and then player X switches to P. So we get sort of anti-clockwise motion around the table with an unstable situation. So actually the optimal strategy is mixed. And so we do talk at AS about pure strategies, which is where it's possible to simply play 1 strategy all the time, and win unstable games like this, where there's a mixed strategy. And player X then has to come up with some way of choosing a probability of choosing it at random, and we have to think about the best, the optimal probability for them. I want to pick up here then on part 2 about the assumptions, and this is something we don't think about much at the moment, but the overarching themes do talk about modelling. We need to talk about assumptions. And we are here talking about a model, very abstract model, but it is a model for a game. And so we have again in the mark scheme here, you can see lots of AO3, back end of AO3, setting up a model. AO 2.3, looking at stating some variables and so on, being clear what they're doing with them, and using that model later on at 3.4. And then in the last part, 3.5b, looking at the limitations of models. So we need to make all sorts of assumptions about the way that X and Y are going to play. For example, to assume that Y is not going to use a pure strategy, because if they do, and they're guaranteed to do so, then the last thing X wants to do is to start using probabilistic means to determine their strategy. So highlighting here how the modelling comes into this discrete math content, even in what might appear as slightly abstract situation. And the last example for you is here from the additional pure, a question about partial differentiation in surfaces. So remembering that all of these things that we've been looking at are AS further mathematics. So while the content might look like it comes from S3 or M3 or is completely new like this, or current D2, that the assessment is at the same level as current FP1. So when the student is taking their AS exams with new further mathematics, they'll be taking 3 papers, one of which is very like the current FP1, the other 2 of which are at the same level as FP1, even if the content looks like it's harder than that. And of course, when they then take if they then take an exam at the end of at A level at the end of 2 years, that's then not at A2 standard, but at a mix of AS and A2. We've done a lot of modelling work to make sure that we get that balance right. And even then, at the A level exams, the balance is about 50-50 or 60-40 in favour of AS style questions and level of demand. So even where we're seeing lots of, say, M3 content popping up, you have to remember that some of that is at AS level of demand, and we will then expect the full range of marks across the mark distribution. So this is a question from an AS paper. It's actually fairly straightforward. We have the equation of the surface, and we're going to find the 2 partial derivatives, fx and fy. We're going to show that it has a stationary point. We're going to find coordinates of a secondary stationary point. And then the second part, we're going to think about the section. So where we hold one of them constant, what does the cross section through the surface look like, and determine the equation. So we have here 11 marks worth of a 60 mark paper, actually all on relatively straightforward content. So we have here the mark scheme. We can see this all looks pretty straightforward, but it's worth picking out that there is 1 mark there of problem solving, that 3.1a, on what looks like a pretty routine question, because there is a decision-making moment. They set both of their partial derivatives equal to 0, but they then have to think, well, this is a slightly strange-looking set of simultaneous equations. What am I going to do with it? How am I going to solve them? So that is that's the problem-solving mark in there. Okay. This is the second part then, looking at the section. I'll leave that again. This again problem-solving. But relatively low level, and thinking about the solution of that quadratic. Okay, so running through the support, running slightly behind time, but plenty of time to have a look at the support here. So we do have these various categories of support we'll just run through. So in terms of planning, we have a teaching order framework. And you can see a screenshot here. This is a complete solution to all 5 terms worth of teaching, co-teaching mathematics and further maths with Spec A. So this makes sure that all the topics are in the right order, the prerequisites are in all the right places. And it shows a division into a 2-teacher model, which I know many of you will use. For mathematics, you have one person teaching pure and stats and the other pure and mechanics. And in the further maths, it looks a bit complicated because there are 4 columns. Once you've decided which 2 options you're delivering in a given block or to a given group of students, you can then delete the other 2, and you end up again with a 2-teacher model that makes sure that all the pure maths ties up in the right way. I should note that in some cases we give the first moment at which you might teach. So in term 3, for example, there's a short introduction to differential equations, because of course once you've got the basics of calculus, a little bit of differential equations is quite a good idea, and you can then develop that later on in year 13 as they develop more calculus techniques. but it allows you then to get on with teaching the second order differential equations and the integrated factors and so on in the further pure course. So all those sorts of interactions thought about and put into place. More detail will come in the scheme of work about the specifics, but we have this complete teaching order framework, so it gives you a starting point. Scheme of work builder should be up and running fairly soon. This is a drag and droppable scheme of work. You can see on the right hand side some choices of things that you could add in. You could add them in here, and then there are associated teaching activities. In the first instance, it will simply be the content, and the teaching activities are going to be populated as soon as we can to get them up and running. We also have these mapping documents, and we have these for each of the optional units in further mathematics. Here, this is a chunk from the mechanics, which shows you an approximate number of hours of teaching time for stage 1 and for stage 2. Now these are very approximate. They're based on a 360 guided learning hours for A level, which gives you 144 hours for AS, 2 terms worth. So each AS option has 48 hours, and then in stage 2 there's 30 hours for the new content, and also another 12 hours simply to spiral back around that stage 1 content. So that spiraling is built into the course. A quarter of the expected teaching time in stage 2 is simply devoted to spiraling back around. Also have the mapping then to where you find each individual part of the specification. We have these check-in tests. The examples here are on the slide for mathematics. There is one for complex numbers already up on the website. These are topic-based tests, which you could use in a number of different ways: homeworks, forms of assessment, tasks as flipped learning, all sorts of things. They have a few procedural questions at the beginning, and then some questions that address the overarching theme, so that look at proof, modelling, and problem solving in a proportion which is appropriate to the strand and the content. They also include, as you can see on the right-hand side there, full work solutions for all of those. So those are mostly written and are making their way through our processes, and will start appearing on the website. We also have lesson elements. These are suggested approaches to teaching particular topics with some bits and pieces. Again, we have some of these written and are making their way through, but we're prioritising the check-in tests and the scheme of work builder, of course, in the first instance. But these will come through in the fullness of time. We also have sample assessment materials, full sets available online. For AS Further Mathematics, we'll have the first set of practice papers by December 2012 and a second set Easter 2018, so that as you go into that first assessment next summer, you'll have 3 full sets of papers to work with. A-level Further Maths, of course, not available until summer 2019 in the first instance. I think the first set should be coming in summer 2018, and there will be 3 sets of practice papers in total by the time we hit the summer 2019. As with GCSE practice papers, those will be held on interchange behind passwords, so you can use them as mocks, and you can use them in any way you see fit. But we hope that you keep them relatively under wraps so that others can use them as mocks. We also have the exam builder tool, which again is drag and droppable. You can search by topic. You can create tests and exams by dragging questions into the paper. You can rearrange them once they're in there, and the tool automatically then creates a mark scheme for you with everything in the right order as well. Currently available, you can use that now for the legacy qualifications, and those qualifications those questions we're tagging to the new content where it works, and the SAMs and obviously practice papers will go into exam builder as well. CUP providing textbooks. They're going through the endorsement process as we speak. They are doing print copies for the further pure core, the statistics and mechanics, and they have confirmed that they will be providing Cambridge Elevate resources for the discrete math and additional pure, including PDF textbooks. They are under the impression that those numbers were relatively small. They can't afford to print them in hard copy. Of course, if they turn out to be popular, then it will be much easier to get some hard copy textbooks provided if there's demand for them. But there will be the full set of textbooks there available. Hodder also publishing for OCR a full set of the further pure course, statistics and mechanics. Not yet confirmed what their resourcing will be for the discrete and additional pure. I believe there will be something, but we don't have quite the same publisher relationship with them. So the full set will come from CUP. For more information, there are various links and bits and pieces. We do have a brand new podcast released last week on looking at A-level maths and further maths. Worth having a listen to that. More of those will be coming. There's also a back catalogue of podcasts available there. At the end of this week, on Friday, we have the Festival of A-level Maths Conference. You can come along to that in the Emirates Stadium in London if you're not already signed up. This is a free day. Find out about planning and teaching Mathematics A. I'll be doing a session on further maths, a slightly more hands-on session looking at some items and so on. And then there'll be a session on teach mechanics and large data sets, technology, and so on and so forth. So lots of great stuff. You can click on the link and go to ocr.org.uk mathsfest and go and have a look at that. We also have coming up in June and July some one-day face-to-face CPD events around the country. These will be run by myself or by Stephen Walker. Take the morning to go through mathematics and the afternoon some further maths and some proper hands-on stuff. So running through some practical mechanics activities, doing some large data set work, and looking at some planning, skimmed work, and co-teachability issues. And so a proper hands-on CPD event, not too much people showing you presentations and talking at you. Lots of good stuff. So again, you can find that through the link and come along. And if you're planning to teach OCR, please do let us know. It makes our life a lot easier if we know the sorts of numbers that we're planning for and so on. And lots of people saying that they're going to teach makes life good. And so you can sign up to teach at the link there. And so finally, OCR Festival of A-level Maths continues all week. There's a session, of course, starting at 5 o'clock today on scheme of work with Stephen Walker. Tomorrow, MEI are running 3 sessions, and then on Thursday and Friday, building into statistics with large data sets, mechanics, underground maths are doing a session, and so on. So lots of great webinars. Do go and have a look at those. So thank you very much. That's the end of the presentation, and we've got about just under 10 minutes to deal with some questions. So we've got one already come up, which I'll deal with. But if you do have some questions, please do tap away. Any questions that we can't deal with today, we'll go into a Q&A resource of some sort, which we'll make available. And you can always email us at maths@ocr.org.uk or phone us. And if you ask a technical mathematics question, you'll get put through to us as subject advisors. So here is the first question. Will the resources you mentioned all go on to ocr.org.uk/A-level mathematics? Yeah, that link goes through to the Reform Hub page. If you go to the Maths Hub page on the OCR website, that which goes through to all the different qualifications, and find your way to the OCR page, that's where all the resources appear. So they all ought to appear on there. If you follow the link with the /A-level mathematics, you will find you'll find links through to the various pages from there. This PowerPoint will be available. Presentation will be available, so you will get that. You can take all that information to your head of department or to other members of departments, other schools. So do please share. Feel free to share all this information. I should also mention that we do have termly twilight network meetings around the country, generally sort of 4 to 6 p.m. after school at a host centre. If you're interested in running those, please do get in contact. Always looking for centres to host those. The A-star, yes, thank you. So the question here is, in terms of grading, how will the A-star work with the new qualifications? Now, the A-star, at the moment, of course, the A-star is based on A2 units, and this thing of getting an average of 90 on each unit, which focuses a concentration in a slightly synthetic way on particular units, and it's really not very good. In the new world, the A-star will be based on the overall mark, and it will be done, my understanding is, in the first session at the least proportionally, so the same number of the same proportion of A grade students. Sorry, let's say that again. So the same proportion of A and A star students get A stars as in the legacy specification. And what will happen after that, we then don't know precisely, but that sort of statistical modelling will carry on. So it will allow you to focus students on their particular strengths or on the whole course, and it rewards a much broader base of knowledge and an engagement with the sort of stretch and demand questions at the end of the papers, rather than on particular things. The PowerPoint, I believe, will be sent to all delegates after the session. I think Laura, our host, can confirm that for us at the end. That's right, thank you. Can a student take more than 2 choices and the best will count? Absolutely. This is true for OCR Spec A and for the MEI Spec B. You can take 2, 3 or 4 choices. If you take 3 or 4, we count the best. Now that won't necessarily mean the highest raw mark because we don't have UMS anymore. So each of the different pathways, this is true for all awarding organisations, each of the different pathways will have its own raw mark grade boundaries. So we may have some results that look a bit strange where your student has been given the maximum raw mark, but they will be given the maximum grade guaranteed and the maximum raw mark within that grade bound. So yes, you can take more than 2 choices, you can take 3 or 4, and on the Spec B, you can take 1 major and any number of minors that you like up to your level of tolerance. Good. So we're approaching 5 o'clock. I don't want to overlap with Stephen's session too much. There's one final question coming. Can I do that for A-level as well as further? Well, for A-level maths, the content is fixed. So everybody does the big pure chunk and mechanics and statistics. So there's no opportunity to do options. So it's only the further, but they can do it for AS further and for A-level further, both of those qualifications. Okay, so I will draw that to a close. If you do have any more questions, do please type them in, and I'll answer those along with the ones we've got here in a Q&A. And thank you very much for coming. It's been a pleasure as always. Stephen Walker will be leading a session now, scheme of work. If you're attending that, you'll need to leave this room and go into the other. Thank you very much.
Thank you for joining us for this online event. We hope you found the session useful. A full recording will be emailed to you tomorrow. If you have any feedback, please complete the short survey that will appear when you have logged out. We will now be ending this session. Thanks again.